Way you
Okay,
go.
okay. Thanks, Carol. Hello, everyone. Thanks for the opportunity to give a talk here. My name is Adrielle. I am a researcher from Athlon Institute of Technology, and I'm here to present you a talk about spatial audio in the context of virtual reality. So I'm going to give an introduction on spatial audio, virtual reality, and what can we do with these technologies because they're quite in a trend now. So to give an overview of this presentation, I'm going to talk about virtual reality and the applications of virtual reality. Also, I'm going to talk about a little bit of quality of experience because this is one of the main subjects of my work also. And I'm going to talk also about spatial audio and its applications and how to measure spatial auditory skills in virtual reality environments. And I'm also want to talk about the future work, what's the perspective of these technologies. So to begin with the presentation, I want to talk about virtual reality. So what's virtual reality and what can we do with this? So here you have a spectrum of the reality. So the first picture is let me put the laser here. You have the reality, so this is a normal kitchen in the real world. We have normal objects, everything that surrounds us is in the reality. And then if you go deeper on the spectrum, you have the augmented reality. That's when you have a virtual object inserted in the real environment. This is the case of Pokemon Go. If you might be aware of what I'm talking about, because this brought this trend of augmented reality for us now. And we also have this augmented virtuality. That's when you have real life objects inserted in the virtual environment. And then to finish, we have the actual virtual environment. That's when everything that surrounds you is virtual. So all of the objects they're virtual, they don't exist, and you can manipulate and interact with them. You are fully immersed on the virtual environment. And what are the applications for virtual reality? The first one is for games, for entertainment, and this is the most popular one. But you can also use it for educational purpose, and we can do some training for example, in the industry, and we want to learn how to manipulate a machine. Then we can use VR to apply this training because it's easier. You don't need to have the actual machine there. You don't need to care about space. So it's simpler, and you can achieve similar results with virtual reality. And also another interesting use case of virtual reality is to design products because you can see your prototype before you have it in your hands in the real world. And this is actually very interesting because there's a variety of software to design 3D models, 3D objects, and then you can actually see these objects in VR as a draft, and then you can manipulate these objects as you want to do this. And another trending application now for us is the collaboration environments, because you have a team and you want to be together, but this has to be done through virtual meetings or virtual conferences. And this is a way to get people together. And this picture here, the fourth picture, it shows the Mozilla hubs. It's actually really interesting how they're doing this because you kind of have your own avatar, and your avatar interacts with the objects on the virtual environment. You can also talk with other people, you can listen to them, you can even take a selfie. This is very interesting, and it's an alternative for days like now, for times like now when we have to do everything online. But what I want to highlight here is the importance of virtual reality in the health domain. And this image here is an example of an application designed to recover motor skills. So they were doing an experiment with paraplegic people with different experimental conditions. As you can see here on this chart, They spent almost 200 hours with virtual reality. So they had a training protocol, and part of this training protocol, almost 200 hours of this protocol was with VR training. And this is a considerable amount regarding the other training conditions. And they were also receiving a tactical feedback, so they had a sensor system to provide feedback to the user. And then they were also collecting physiological data, as you can see here, the EEG signals from the brain, EMG here, signals from your muscles. They were trying to understand how the user behaves during the task. And this is very interesting because in VR you can achieve a high level of immersion. And in this example here, especially this one, people were kind of able to feel their virtual legs. And this is because of the high level of immersion that VR produces. Um, but there are some other applications that are related to other disorders. I have an example here on the right. This is for children with autism. So they built like a fairy tale environment. They simulated this fairy tale environment, and this is one of the benefits of VR because the flexibility of the virtual environment is very important, especially when you're dealing with children, because you want to get their attention, you want to get them focused on the task that you want them to complete. And this bottom picture here is from a PhD in our lab in Sloan, and he built this system to assess speech and language disorders. And he's also comparing different platforms like VR with the headset here, but he's also working with with augmented reality and with tablets. So he's trying to understand also the interaction with the system. And this is something that you need to be aware of when you're working with VR. Um, and okay, we have an application and it is very interesting, very engaging, but how do we measure if the user is actually enjoying this experience? So for this, we have quality of experience, that is the degree of delight or annoyance of the user of an application or service. So it is basically trying to understand this relationship between the user and the application. And for this, we have some influence factors. The first one is related to the system, to the application. In VR, for example, we have a headset. This is the system. This is the hardware that we are using to render the virtual environment. And the next influence factor is the content. So what are you displaying to the user? What are you showing the user? Are you showing a virtual environment like the example with a fairy tale environment, or a real environment, or a kitchen, or whatever? And next, there's the context that is very important, because if you're dealing with children, it's different than you're dealing with adults, for example. And it's the same for women or men, and it depends on your target audience, and your target audience will affect the design of your application. And also, you need to be aware of the perception of the surroundings, because with VR, the main input is our eyes. So actually, it's what we are seeing. So we need to be aware of this. But you can also have objects, and you can have a controller, for example, that you want to manipulate objects. So you need to be aware of how people are perceiving the surroundings. And QoE also has this task of giving insight into the user state, because we're trying to measure the workload, for example, or even the level of immersion that is very important when we are talking about VR. But how to how spatial audio works with VR and with quality of experience. So it works just like another sensory inputs like vision, or another tactical inputs, for example. And Spatial audio is a technology that has more than one audio channel, because if you have one audio channel, it's going to be mono. Let's say you have a headset like mine, and you can hear from left and right. If you have mono, you're going to listen to the same thing in both of the channels. And stereo, that is the most famous, the most common one, is when you have a left channel and a right channel. But you can have more than two channels, and then you go to sonics. Then the perception of the sound is completely different. And then spatial audio is used to enhance the perception of distance and movement. And it also helps with our sense of presence, so it increases the level of immersion. So I have an example here. It would be ideal if you had your headphones on, just for you to listen how this works. This is a video from Dolby. Dolby is a company that works with spatialized audio, uh, mainly with software to render this audio. So I'm just going to show you here.
Welcome to Dolby Atmos. Please put on your headphones. It's a new way to experience sound. Unlike stereo, which is limited to two audio channels, Dolby Atmos can manipulate individual sounds in 3D space to position sounds all around you. Sounds can move above you, far away, or right up close. Let's compare. This is stereo, and this is Dolby Atmos. Dolby Atmos can build worlds of sound without any storage. It catches all the little details, puts you in the center of the action. It sounds just like the real world.
So that's okay. As you can see, if you had your headphones on, it's a completely different experience. It's just like you're there living the situation, and that's why spatial audio changes the our sense of presence there. That's why it's so important. Um, change here the slide. Okay, so when we're talking about spatial audio, it's mainly used for communication skills and to alert people. Let's say you hear something cracking on the floor, you're going to look, it's going to call, get your attention. And also to separate target from distractors. This is related also to communication skills, because, for example, when you're trying to learn a language, you're trying to learn the phonemes, and you need to be able to discriminate the different phonemes, because phoneme from Chinese is different from French or English, and so on. So you are able to differentiate these small sounds, and this is related to spatial audio. And you can also use spatial audio to orientate yourselves. This is also another thing that, for example, bats use this. This is all related to spatial audio. And when we talk about spatial audio, there's a classification of the localization errors. The first one is the localization blur. That's when you perceive the sound to be actually very close to the real location in a range of 30 degrees, for example, and it can be either left or right. And there's also front back confusion, when you perceive the sound to be in an opposite direction. You should have an animation here, I don't. Okay, but it should be, for example, if the green one is the target, you should perceive the sound to be somewhere here. And this is important to understand, because some people they aren't able to perceive sound properly. So people with auditory processing disorder, for example, they cannot differentiate sounds in space. So this can be very frustrating, because we're constantly doing this. And but how to measure um, how to measure these auditory spatial skills? So there's a test for this condition, and this is called listen and spatialized noise test. And the objective is to pay attention to the target sound source that is named T here. So in this task, you have different distractors to confuse the listener, and you have also different position for those distractors. Let's say here I have one distractor, and on this situation it would be like three of me were talking at the same time, and you just want to pay attention to one of me, and because we're all at the same position. And here it's the same situation, but like three of me in three different positions, and for this one three different people talking at the same position. And here I think it's the most common situation in real life, when you want to pay attention to one target and everything that surrounds you is a noise. Let's say when you're in a party and you're talking to someone and there are other people chatting next to us, you ignore all of these sounds surrounding you and you pay attention only to the person you're talking with. So how to measure these spatial auditory skills in VR? So there's a relationship between the sound position and the perceived position. As you can see here, I have the position of the user, and I also have the position of the sound source and the position of the perceived sound. When you have a localization arrow, these positions, they're different, and there's a distance between you and the direction of your head and the perceived sound and the sound source. And this is important. This distance is also important when you're trying to measure the time to find the target, so the time to complete the task. This is very important. And another thing that is important from this graph is when you have the location of the perceived and the sound source, you can classify the localization error. So it can be, as I said, front back confusion or localization blur. And there are also another metrics related to workload, especially when we're dealing with VR. That is a new technology. We need to understand how people manipulate the objects, how people are going to do the task, because it might be something completely new. This application, this person has never experienced something like this. So we also need to be aware about workload and about the level of immersion, if this person is fully immersed in the environment, or if this person is paying attention to something outside the virtual environment. And for future work, we need to explore the benefits of virtual reality regarding the head movement, because you have a headset, so you are able to tell the location of the head, and you can also establish a relationship between the head movement and the performance. And you also have the analysis of the physiological data, because you can collect, for example, in one of my experiments, we are collecting heart rate and electrodermal activity and gaze data, and we can analyze this on the frequency domain, for example, because currently there are lots of tests with the time domain, but we can also change this to be on the frequency domain. And we can also compare the benefits of the visual stimuli in VR, because even though this is an application developed for audio, we need to measure the impact of other objects in our field of view. So this can help with the localization task. These objects, they can help because you can associate what you're listening to with what you're seeing. And but they can also be distractors. They can also stop you from performing the task. And VR allow us to control the content we want to show to the user. And this is something to be aware of, because this is one of the benefits of VR. And I like to thank you. And if you have any questions, just let me know. And thank you